In the final 60 seconds of a human life, something happens that most people have never been told about. Not a light, not a tunnel, something measurable recorded on a machine in a hospital room. A brain that is supposedly shutting down produces one last surge of activity, stronger than almost anything measured all day. This isn't a theory pulled from a near-death account. It's from an EEG, a machine that doesn't exaggerate and doesn't believe in anything. We're going to walk through exactly what your mind does in that final minute, second by second, using only what's actually been recorded. But first, you need to unlearn something, because the last 60 seconds assumes death is a single moment. It isn't. Doctors define death two ways: the heart stopping or the brain stopping. Both sound instant. Neither one actually is. For decades, the assumption was that brain cells die within minutes of losing oxygen. Fast, irreversible, done. In 2019, a team of researchers tested that assumption directly on a mammal brain 4 hours after death. They circulated a specially designed solution through a pig's brain that had been dead for 4 hours, and something they weren't expecting happened. Circulation partially returned. Cells that should have been long gone were still structurally intact. Some of the smallest working parts of those cells, the ones that generate energy, were still functioning up to 10 hours after death. Not thinking, not conscious, but not finished either. So when we talk about the last 60 seconds, understand what we actually mean. The last 60 seconds where the whole system still works together, not the last 60 seconds where anything in your body is technically alive, because parts of you keep going long after the rest of you has already left. And that blurry, unfinished quality of death shows up in an even stranger way, not just in a lab, in real hospital records, more often than most people realize. It's called the Lazarus Phenomenon, named for the biblical story of a man raised from the dead. It describes something startlingly literal. A patient undergoes CPR, shows no response, is declared dead. The resuscitation team stops and steps back. And then, minutes later, without anyone touching them again, a pulse returns. As of the most recent count, researchers have documented 76 confirmed cases of this across 27 countries. Patients ranging from 9 months old to 97 years old. In most documented cases, the heartbeat returned within about 5 minutes of stopping resuscitation. In one of the most extreme recorded cases, it came back 220 minutes later, nearly 4 hours after everyone in the room believed it was over. In one case on record, a 67-year-old woman was worked on for a full hour before doctors called it. About 50 minutes after they stopped, she began showing signs of life again. This isn't an urban legend passed around in break rooms. Surveys of intensive care and emergency physicians across multiple countries found that roughly a third to half of them have personally witnessed a case of it. Nobody fully understands the mechanism. One leading theory involves pressure trapped in the chest during compressions, slowly releasing once they stop, allowing a delayed final beat to occur on its own. But theory aside, the fact stays on the record. The declaration of death and the actual end of a body's capacity to continue are not always the same moment. Some hospitals have since adjusted their protocols, building in a longer observation window after stopping compressions, specifically because of cases like these. Which means, even the professionals whose entire job is identifying the exact instant a life ends have learned from direct experience to leave themselves a margin for the possibility that they are wrong about the timing. Keep that in mind, because everything from here forward happens inside that same uncertain margin. With that established, here's the actual countdown. Second by second, this is what's been recorded. We're inside the window now. Somewhere in the final minutes, most people stop responding entirely. They don't open their eyes. They don't speak. Families are often told, gently, that their loved one can no longer perceive anything at all. Researchers decided to test that claim directly. Instead of assuming it, they played patterns of musical tones to hospice patients who were completely unresponsive, the kind of unresponsive doctors typically describe as gone. They weren't just checking whether sound registered as noise. They were searching for a specific brain signal called a mismatch response. a signal that only fires when the brain notices a pattern has changed. And in patient after patient, hours from death, they found it. Brains that could no longer move a single finger were still tracking changes in a sequence of musical notes, not just hearing, recognizing pattern, still doing the quiet work of listening long after every other system had gone dark. Compare that to a healthy, fully conscious brain doing the same task, and the response looked strikingly similar, which means in the actual final minute of someone's life, a familiar voice in the room may be one of the last things still getting through, even when nothing on the outside suggests anyone is listening. 20 seconds left on this stretch of the countdown, and the loudest part of this whole story is about to happen. In 2013, a neuroscientist studying dying rats made a discovery nobody was looking for. After the heart stopped, the rats' brains didn't just power down in a straight line. For about 30 seconds, they produced a surge of gamma waves, the fastest, most organized electrical activity a brain can generate, normally tied to focus, memory, and alert thought. It took 9 years for anyone to confirm this in an actual human being. Not because it doesn't happen in people, because almost no one dies while already hooked up to a brain monitor for an unrelated reason. In 2022, it happened anyway, by accident. An 87-year-old man was being monitored for a seizure when his heart suddenly stopped. For roughly 30 seconds, right around the moment his heart stopped, his brain did exactly what the rat's brains had done decades earlier. A surge, a spike in the same frequency. A follow-up investigation in 2023 found the same pattern again in a separate group of patients taken off life support. Here's the detail almost nobody mentions when they tell this story. Most of the brain's electrical activity actually collapses at this point. Power drops across nearly the entire brain, except in one very specific region, the temporoparietal junction, a zone tucked behind the ear, where the brain assembles the felt sense of being a self, located in a body, in a place. It's the same region that activates during out-of-body experiences and during dreaming. Nobody studying this is claiming it proves consciousness. A machine detecting gamma waves is not the same thing as knowing what, if anything, a person is actually experiencing. But it does undercut something almost everyone assumes without question, that the brain simply switches off like a light. In its last organized act, it doesn't go quietly. It goes loud and it goes specific. But the surge isn't actually the last event. There's one more wave still to come, and it's stranger than the first. Minutes after a brain's normal electrical activity, the kind measured on a standard EEG, goes completely flat and silent, something else is quietly building underneath. Researchers call it a terminal spreading depolarization. Doctors who study it less formally call it the wave of death. It's not the same signal as the gamma surge. It's a slower, massive shift in electrical charge that spreads through brain tissue almost like a tsunami, cell by cell, region by region. For years, this was only documented in animals. In 2018, researchers finally recorded it directly in dying human patients using specialized electrodes placed on the brain's surface. What they found matched almost exactly what had been seen in rats decades earlier. Several minutes after the brain appeared electrically dead by every standard clinical measure, this final wave arrived anyway. In one recorded case, the heart's electrical signal kept firing on the monitor for a full 30 seconds after it had already lost the ability to actually pump blood a heart, going through the motions of beating with nothing left to move. Here's the detail that should genuinely unsettle you. Researchers now believe this wave marks the real turning point, the moment the toxic cellular cascade inside neurons becomes very difficult to reverse. But difficult to reverse is not the same as impossible. If circulation is restored quickly enough before this wave fully completes, some of that cellular damage may still be undone, which raises raises a genuinely uncomfortable question that resuscitation researchers are now debating openly. How do you define the legal moment of death when the brain itself has a built-in, several-minute grace period nobody knew to look for? One researcher working on this exact question noted that it reframes how doctors think about organ donation timing, where death is currently declared somewhere between 2 and 10 minutes after the heart stops, right in the exact window where the second wave is often still unfolding. So by the time this wave finishes, more time has usually passed than most people would ever guess. The brain isn't dying in one instant, it's dying in stages, each one slower and stranger than the one before it. Sometimes though, the story doesn't end with a machine reading. Sometimes it ends with a conversation nobody expected to happen again. It's called terminal lucidity, and it's been written about in medical records for roughly 250 years, almost entirely ignored by mainstream science until recently. It shows up like this. A person with advanced dementia who hasn't spoken a coherent sentence or recognized their own family in years suddenly sits up, speaks clearly, calls people by name, asks how they've been doing. Then, often within days, they're gone. One study following 100 consecutive deaths found roughly 6% of patients showed an episode like this before dying. A separate hospice survey found 7 out of 10 caregivers had witnessed it at least once in their careers. It's not limited to dementia either. Case collections include patients dying from brain tumors, strokes, meningitis, schizophrenia, and severe mood disorders conditions, with almost nothing biologically in common, except that all of them produce the same strange return of clarity near the end, which suggests this isn't a quirk of one specific disease. It might be closer to a shared mechanism of the dying brain itself, something the brain seems capable of doing, almost regardless of what damaged it in the first place. It's messier than the stories make it sound though. One recent study found these episodes can last anywhere from 30 minutes to several days. About 22% of people who experienced it died within 3 days afterward, but others lived for weeks, some for months. So it isn't a reliable countdown clock either. It's something else entirely, a door that sometimes opens right before it closes for good, on a schedule nobody has been able to predict. So that's what's been measured from the outside, by machines and by the people sitting beside the bed. But a small number of people have come back from the edge of this process and tried to describe what it felt like from the inside. Most people revived from cardiac arrest report, remembering nothing at all. That part rarely makes it into these videos, and it matters. This isn't universal. But in 2022, researchers led an investigation into the accounts of those who did remember something, specifically comparing them to hallucinations and drug-induced experiences, to see if they actually looked the same on close inspection. They didn't. The reports that did occur clustered around a specific, repeating set of features, a sense of separating from the body, an unusually heightened, almost vast form of awareness, and in many cases, a clear recognition in the moment that they were dying. Structurally, researchers found this pattern doesn't closely resemble what people typically describe on psychedelics or during ordinary dreaming. That doesn't prove what any of it means. It doesn't confirm an afterlife, and it doesn't rule one out either. What it does confirm is narrower and in some ways stranger. Whatever the dying brain generates in these final moments, when it generates anything at all, it isn't random noise. It has a shape. That was about the shape of these experiences. But one study went further and tried to check whether any of it could be verified against real external events. It's called the AWARE-2 study, and it followed 567 people who suffered cardiac arrest inside a hospital. Only 53 of them survived. Of those, 28 were well enough to be interviewed afterward. 11 of those 28, just over a third, described memories or perceptions consistent with being conscious during a period when, clinically, they should not have been. Break that down further. and it gets more specific. About 40% described a general sense of awareness without being able to recall clear details. Around 20% described features consistent with what researchers now formally call a recalled experience of death, and a small number, close to 3%, reported something researchers take even more seriously: real verifiable perception of actual events and sounds happening in the room during their own resuscitation. To test this directly, some hospitals set up hidden images on tablets and specific sounds played through headphones during the resuscitation itself, so that if a patient later described seeing or hearing something, it could be checked against a real, predetermined target. No patient in this particular study successfully recalled the hidden images, but the auditory and visual awareness some patients described did line up with real, confirmed events that had actually happened in the room. At the same time, researchers monitoring brain activity found something almost unbelievable. During active CPR on hearts that had already stopped, some patients showed EEG patterns spanning the same range seen in fully alert, conscious people. Not constantly, not in everyone, but in a portion of patients during chest compressions on a heart with no pulse. The lead researcher on this study said these findings crack open a real, if barely understood, dimension of human consciousness, one that only becomes visible right at the edge of death. Nobody involved in this research is claiming it as proof of anything beyond biology, but it is proof that whatever is happening in that window isn't nothing. It's measurable, it's repeatable across hundreds of patients, and in a small number of cases, it lines up with things that were actually physically happening in the room. The window closes. 0. So here's what we can actually say about the last 60 seconds without guessing beyond the evidence. Hearing likely still works, tracking real patterns right up near the end. Cells don't switch off on command. Some of them keep working for hours after the systems around them have already failed. Sometimes, the declaration of death itself turns out to be premature, not by minutes of guessing, but by documented, recorded minutes where a body simply wasn't finished yet. In a number of recorded cases, the brain's most organized act isn't collapse. It's a surge, a burst of the same kind of activity tied to focus and memory, concentrated in the exact region that builds your sense of self. Even after that surge fades and the brain appears completely silent, one more wave can still be building underneath, arriving minutes later on its own delayed timeline. And in a small, carefully studied fraction of cases, whatever a person experiences during all of this doesn't just feel real to them. It appears to actually correspond to things that were happening in the physical room around their body. We waited 9 years between the first sign of the gamma surge in a dying rat and the first accidental proof of it in a dying human. That's not because any of this is rare. It's because almost nobody is watching in that exact window with the right equipment already running at the exact moment it matters. Maybe that's the real reason this topic still feels so unknown. Not because science has nothing to say about it. Because the one process we most want to understand is also the one we almost never get to fully observe. And maybe that's worth sitting with, just for a second. Not with fear, with the strange, quiet comfort that whatever these last 60 seconds actually are, they are not a single instant, they are not silence, and they are not nothing. They might be the longest, loudest, most specific thing your brain ever does.